Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back for an update on the Musical Paradise. Been working on this little amp, got parts ordered. I actually ordered some EdCore output transformers to try in this thing, just to kind of see what that gets us. Never used any of their little open frame, lower budget ones. We're going to see what those are all about. That's probably going to be in the next video. But this one, I'm going to show you the mods that we're doing to the circuit board. We're changing a couple of resistors and changing a couple of capacitors, and then we're trying strapping the input tubes. And so, let's get busy showing you what that's all about. Okay, we're back inside our little Musical Paradise amp. And the last video I went over drawing load lines for this triode strapped pentode that is the driver of this amplifier. And we also went over the size of the bypass capacitors that were going to be needed, plus the resistor sizes that we were going to be changing on the plate and the cathode of the driver tube. And then this is the plate resistor. One of the changes we made is we triode strapped the tube by connecting this point here to this point here. Let me zoom in here and see if I can get a little better shot of this. So this is our plate load resistor. This is our B plus voltage that goes to the plate. This is the plate pin right here. Okay? So we're going to take the voltage from the plate and put it on the screen through this 510 ohm resistor. So we've got the plate connected to the screen through this resistor which triode straps the tube. We changed this resistor to a 4.7K to boost up the B plus voltage on the other side of the plate load resistor. And then here's our plate. Then it's kind of hard to see. Maybe I can see if I can get the amp tilted up a little bit where you can see this a little better. And if you look in here, you can see that this resistor right here is the cathode resistor. And we changed it down to 680 ohms. Okay? So our goal here was to get the bias point moved down where we have 4 volts on this pin right here, which is the cathode of the driver tube. And then we're going to see what voltage we have here. I'm guessing it's going to be about 140 volts, but haven't powered the amp up to check. But that's what my calculations show we should be seeing. So we're going to power this guy up. So the first thing we should see is about 22 volts on the cathode of the output tube, just to ensure that everything's working like it was. And this other channel should be the same, right there at 22 volts, so we're good there. The other thing you'll note is the difference in these two capacitors. And you're probably thinking, look at that teeny tiny little capacitor. Why do we have such a small one? Well, this is a 150 UF, but it's also 250 volts. Well, there's only 22 volts across that capacitor. I have no idea why you would put a 250 volt capacitor when it's never going to see anything over 22 volts. So we went with this little guy, which is a 50 volt, 330 UF audio spec bypass cap from MKIII. It's their top shelf. These blue ones are the high-end audio ones. And so we got a pair of those to put in it. We've installed it on this channel. And then here is the bypass cap for the driver tube cathode, and it's a 220 UF 25 volt. And it looks like that. So we went from 100 UF to 220, It went from 150 UF to 330, and that should help the low frequency response. And also, that we talked about in another video, we reduced the size of the grid leak resistor on the output tube to a 470K. Initially I said 510K, but 470K is absolutely within spec, so a few people that were kind of freaking out about that, it's not even an issue. Let's check the volt on the plate of our driver tube, and this is without the shade feedback connected, and it's right where we thought it was going to be at 140 volts. And then the cathode is right where I expect it to be. We got 3.8 volts, which is very close to the 4 volts that we were expecting. So we got the bias point nailed down. So the last thing I'm going to do is I'm going to connect up our shade feedback resistor that goes from the plate of the output tube to the plate of the input tube, and we'll come right back and check the final voltage on the plate of our input tube, and then we'll hook this thing up to the audio analyzer suite and see what we get with these changes. Okay, so you can see we have our plate-to-plate local feedback, or some folks refer to it as a shade feedback resistor, and that's now connected. And let's make sure we still have the tube conducting, and there's our 4 volts that we were initially talking about wanting. Now that we have some extra plate voltage, and now we're right at 150 volts on the plate of the input tube. And on the other side of this plate load resistor, we see 330. So we're very close to splitting that 330 volts by the time it's on the plate of the driver tube. And again, we're real close to our target of 4 volts on the cathode that we had initially identified on the load line. And like I said, if we're 1/10 of a volt in one direction or the other, it's really not a big deal. So we hit our targets, and this tube's now being run still well within its safety zone. I can show you later in the video about what these bias points look like on a power or a dissipation calculator. But now we're ready to hook this thing up to the audio analyzer suite, that I've got the tubes operating where I want to see them operating. And real quick, I'll just kind of show you. Here's the plate voltage on the output tube. Get 328. And then again, on the cathode, got just under 22 volts. And so we'll run those calculations as well. So let's get this thing on the audio analyzer suite and see what kind of performance this thing has now that we got the tubes operating in a really nice place. Okay, so here's the THD versus power pull on the unmodified channel. And this is with the little red RCA tubes and the 6L6 GC RCA output tubes. And as you can see down here in the nether zone, it's got 1% THD. We cross over 2% at about a half a watt of power. At 1 watt, we've got 3% THD. At 2 watts, we've got 4.5. At 3 watts, we've got a little over 5% THD. And right here at 5 watts, we've got 7% THD. So let's switch this up to the channel that we just finished modifying and see what this little amp does with that front pentode triode strapped and biased up a little hotter, well, a good bit hotter, into a zone where it should be happy. as I showed you on the plate curves. And here we go. Now it does have less input sensitivity, but look how low that distortion is. And at 1 watt, we're under 1%. 2 watts, we're about 1.5. 3 watts, we're at 2% distortion. And then right around in there, it looks like it's where it starts trying to clip. And we got 6 watts at 3% distortion, which for a EL34 type amplifier, that's some pretty decent power. And this is with what I believe are non-optimal output transformers. And so let's just see here if it is in fact clipping right here. We look, you can see the input is at 1.3 volts RMS. So we'll go to our scope, sine wave. We'll go to 1.3 volts here and see what this looks like. And you can see right on the bottom here, it's just starting to clip. And let me kind of show you real quick what that looks like. At 1.2 volts, there probably isn't going to be any clipping. Yeah, see, it's nice and even there. There's no clipping. And then if we go to 1.4 volts, we're probably going to see pretty heavy clipping. Yep. You can see that's pretty nasty. And so, I mean, possibly we could tweak things around in the amp a little bit and try to get it to clip symmetrically. But I'm not super concerned about that because we're getting pretty good performance out of this thing now. And you can see at 1.6 volts it's starting to round off the top. So, yeah, it's asymmetrically clipping. Could we tweak a little more power out of it? Possibly. I'm just not really that concerned about it. If you guys are, you can keep working on it, but I'm pretty happy with what I'm seeing here. Again, at 1.2, we got no clipping. And at 1.2 volts RMS in, we're right at 5 watts, which is about what I would expect this amp to get used at. And I think you could use it easily in this 2 to 4 watt range without any hesitation. And then you've got this extra couple of watts on the top end here for transients that you're not going to hear distortion from. So here's the thing that I'm really curious about. Let's do a pull on the original channel with the frequency response and show you what we started with. And then let's see if we've been able to improve it just by changing the way the tubes are operating. And the reason I'm checking one channel at a time, when you have 2 channels in an amp that are wired this differently, you really can't test them both at the same time because you'll get really weird results. And again, it's never a good sign when you see this frequency versus THD coming up out of the bottom of this scale. And as you can see, once you get under 1K, it starts rolling off pretty heavy. So you look at this upper left-hand number, this one up here, you can see that it's almost 0 dBs right along in here. And then as you go down here, at 100 hertz, we're down 1 dB, and we're down 3 dBs at 40 hertz, which even with my RP600Ms that only go down to 40 hertz, you are going to hear 3 dBs of roll off. And then down here at 20 hertz, we've got 7.5 dBs of roll off. And that's why I was hearing what I was hearing, that this little amp doesn't have any bass response. So let's switch to the modified channel and see where our bass response is now. And again, this is before I've changed the output transformers. which I'm hoping will give a nice improvement. But who knows? It may be one of those things that you don't need to change the output transformers. You just need to do these minor rewiring modifications that I've done to the tubes to make this thing really sing. So here we go. We're still getting some roll off here. Again, if you look at this left number up here, this is close to 0 dB. It's like 0.2 positive. And this time when we get down to 100, we've lost about 0.6 dBs. And then our 3 dB roll off point, it's around 28 hertz. So we've lowered the negative 3 dB roll off point to under 30 hertz now. And at 20 hertz, we got about 4.5 dBs at 20. So we've picked up a good bit of bass response, and it's a lot flatter in this region here, but it's still just rolling off more than I'd like to see. And I think that's a factor of the output transformers. At least I've got my fingers crossed that's what's going on. If putting the output transformers in it fixes this low frequency roll off, then we've got a winner. So let's look at the THD versus frequency real quick. We're going to go ahead and pull the channel that we've got connected, which is the modified one. And we're pulling it here at 1 watt of power. And you can see down here at 20 hertz, we've got almost 20% distortion. But as we get down to 100 hertz, it's down to 3.2%. And then by the time you get down to 400 hertz, 500 hertz, it's under 1% distortion all the way across the board. So I think we can help smooth out this part in here with some better output transformers, because that's usually what causes this high distortion at low frequencies. It's just the output transformers aren't ideal for what we're trying to do. And then real quick, let me swap over to the other channel for one last pull here and show you what this frequency versus THD is like on the unmodified channel. As you can see, we've got a very similar high distortion down in the low frequency range, but then it just barely gets below 3% distortion when you get up into the higher frequencies. From here to 1K to 5K, it's right at 3% distortion, which is like 3 times the distortion that the modified channel has. So we are definitely moving in the right direction. We just need to do this output transformer swap and see if this will take this little amp where we want it to be. So I'm going to get to work on that, and we'll see what that looks like later on. Well, as you can see, these circuit changes have made a big improvement in the THD as well as the power output. Still not getting a lot of bass response. It's improved and should be audible. And for a lot of systems, its 40 hertz response is probably going to be good enough. And like with my little clip speakers, they only go down to 40 hertz. The only problem would be if you were going to do some sort of a powered sub deal to try to really get down into the bass. If the amp's not putting the bass on the output jacks, then you're not going to see it on the sub either. And so there is that. So there's no way to, like, I guess you could crank your sub up, or I don't know. Anyway, not going to get into that deal. I'm hoping that with this output transformer change that we'll pick up some of that low frequency response, but we're going to save that for the next video. And again, you saw the curves on the power versus THD. We had 7% THD at 5 watts was what this thing was doing before, and we got substantially better. So anyway, don't want to get into the point where there's nothing left inside this amp that it started with, but I do want to kind of see what the output transformer things do. And I did, so you can see here, I've got Right now we've got a little Ed cord kind of breadboarded into it, and the way this little amp has those little screw connectors for the output transformer leads, it makes it easy to, demo this thing with different output transformers. So that's the next video. We're going to run through 3 or 4 different output transformers, and then we'll do a final video on the mod series showing you in detail how to mod the other channel, because we left one stock and one's modified, and then probably wrap it up with a subjective listening review. And then I guess the other thing is, honestly guys, I think I'm just burnt out on doing these kind of revisions to these defectively designed or engineered China products. It takes a lot of time and energy, and at the end of the day, I'm not even coming up with a product or something that I could sell to benefit from other than making YouTube videos and helping people out that have bought problematic products. And honestly, it's just gotten where it's not fun anymore. I've gotten this whole week, I've just watched TV and done other stuff because I didn't even feel like coming downstairs and working on my bench. And I've got 2 or 3 other products or things like that 6C33C amp I want to work on. I got 2 or 3 other projects in the hopper I want to work on, but I know I can't stop working on this, or I need to do this one next, and it's just killing my productivity. And so, like I said, I could have made the decision. This is going to be the last one of these I do for at least a good while. So thanks to all you Patreon members, you folks that have made donations at the site. I know specifically some of y'all made donations for me to keep working on this project and begged me to, and it's one of the reasons I've stuck it out and didn't just ship it back to the guy. I really didn't feel like doing it, but you kind of convinced me, and so I'm going to finish this one up. And again, until the next video, have a nice day.